Last day of arson study for homework. We are going to study explosives today.
Okay, so today we're going to be talking about explosions. And if you have a fire and an explosion, together that's a combustion reaction. And remember, the results, the products of that combustion reaction is CO2 plus H2O, always. An explosion is a chemical action resulting in rapid expansion of gas. Basically, the difference of an explosion and a fire is that an explosion is so much faster, more dangerous, and greater than a lot of times a fire is. Each explosive is classified on the speed at which they decompose or detonate. And there are two types of explosives. Low explosive, where the speed of burning, again that's supposed to be an arrow, is less than 1,000 meters per second. And then our second type is high explosives, and that's when the speed is higher than 1,000 meters per second. The detonation is the rapid reaction, and then it's followed by a high shock wave. The danger of explosions is that you have this shock wave and you have flying debris. Okay, let's talk about low explosives in more detail. So basically, they are used for ammunition and skyrocket, and they become very dangerous when they're confined. There's two big examples, black powder and smokeless powder. And you can have two different types of smokeless powder. You can have a single base, which is just the nitrocellulose, or you can have a double base, which has the nitrocellulose and the nitroglycerin, and I'm sure you've heard of nitroglycerin before. You usually put black powder in safety fuses, and what it does is it carries that flame to the explosive charge. You need fuel and an oxidizing agent for low explosives, and you can make one with potassium carbonate, that's supposed to be a 3 instead of a 4, plus sulfuric acid plus sugar. Let's go on to high explosives. There are two different types of high explosives. You have primary and secondary explosives. Primary explosives are easily detonated by heat or shock, and they're used to detonate other explosives, similar to low explosives. An example of a primary explosive is lead azide, and that's used in blasting caps and detonates violently. Secondary explosives are insensitive to heat, and they will shock and burn rather than detonate. Several examples are dynamite. Remember, back from Alfred Nobel, he used that. Sodium nitrate, and it's non-initiating. TNT was used in World War II. Petanite is used in detonating cords and primacords. ANFO is cheap and homemade. As a secondary explosive, it's a high explosive, so the speed is very rapid. It's used by terrorists, and the reason it's called ANFO is because it's made up of ammonium, nitrate, fuel, oil. ANFO. You have heard about ANFO on the news several months ago when the explosion in West Texas happened. The reason the explosion in West Texas happened is because there was too much ANFO on the plant, and when the fire reached it, it exploded. Each plant is supposed to write down how much ANFO they have so the firefighters, if there is a fire, will know, and then the safety coordinator or expert can alert them to this hazardous, dangerous material on the plant. In the West case, that plant didn't have a safety coordinator. Actually, they named one, but that person never knew that they were the safety coordinator. It wasn't well managed in that aspect, and I bet a lot of things will change because of that West disaster. Okay, collecting and analyzing explosives. The most important samples are obviously from the explosion scene, and you want to look for the presence of that crater, and you want to collect that ash and soot from that crater. You want to search the area. using an IMS, an ion mobility spectrometer. Collect all the porous material at the origin, seal, put it in separate containers, make sure it's all labeled. You look at the debris under a microscope and you rinse it with acetone. Then you can analyze it first using the color test, TLC, HPLC, or the IR, remember the infrared, for organic materials. You use X-ray diffraction for inorganic materials. That concludes our notes on arson.
Okay, this is the last reading on this case, and I want you to be prepared to explain what you think, if you think he's innocent or guilty, and tell me reasons why.
Okay, happy reading. Notice that it just took the jurors a little over an hour. Also, notice that there was some bias. Okay, so be ready to defend your opinion of the case and if you think Willingham is guilty or innocent tomorrow.
Okay, here's what to know for your last quiz. What is an explosion? What's the difference between low and high explosives? What are examples of each? When do low explosives become lethal? What are the two types of high explosives? And I want you to know examples of the primary explosive. We talked about the example was lead azide. And then we talked about several examples of the secondary explosives. And I want you to know some examples and where they're used, like TNTs for military, things like that. And then how do you examine explosive residue? So you can look at it under a microscope. What do you wash it with? What do you rinse it with? You can do certain tests, and I talked about the different tests, and I want you to know those as well. All right, see you tomorrow.